We're going to move on, and we have another presentation now coming up from Dr. Linda Horton. Let me make a quick introduction, and then we will segue into hearing an update from her. Hello, Linda. Thank you for making some time for us today. For those of you who may not have met Linda before, a little background. Dr. Linda Horton is the Associate Director of Science for Basic Energy Sciences in the Department of Energy, Office of Science, which has an annual budget over $2 billion. And Basic Energy Sciences is the nation's leading supporter of fundamental research in materials science, chemistry, geosciences, and aspects of biosciences. BES is also a major supporter of scientific user facilities. Many of you on the call today, on the meeting today, perhaps work at one of the BES user facilities. This includes the nation's premier X-ray light sources, neutron scattering facilities, and nanoscale science research centers. Since joining DOE in 2009, Dr. Horton has been extensively involved in interdepartmental coordination activities, including serving as the DOE's Office of Science Management Lead for batteries and energy storage, the Office of Science Early Career Research Program, and is a past co-chair for the White House Office of Science and Technology Policies led Materials Genome Initiative. Her BES roles have included interim leadership of the management team for the newly established Energy Frontier Research Centers, serving as the materials lead for international activities that included workshops with the European Union on energy storage and critical materials. And since 2016, she's led the BES teams responsible for 7 strategic basic research needs workshops and roundtables and the associated brochures and reports. So, and that's just some of what I've found is Linda's existing duties and background. So thank you, Linda. Over to you for making some time today to give us an update on the BES activities.
All right. Thank you very much for the introduction, Dan. That was from the BES website, and I probably omitted what to this group might be the most important thing. Prior to coming to DOE, I was the director of the Center for Nanophase Material Sciences at Oak Ridge. So I have close ties to user facilities in my background. So thank you very much for the invitation to give an update on what we're up to in the scientific user facilities. I was intrigued by the previous discussion and could have talked about that particular aspect of what we're doing for my entire presentation, but actually did not include much on that. But that is increasing the diversity of our user community is a really important aspect of what we're emphasizing. So thank you for having that session. I don't think I need to dwell on this. This was already included in my introduction, that BES, obviously, for those that were not aware, has a big emphasis on user facilities in our overall budget. And one aspect that was highlighted in the previous session is that a new dimension is ensuring that we have broad participation in our user communities, as was so nicely articulated previously. If we look at our user facilities, it's just a reminder that we go across the country, and our users come from across the globe. Turning to what's going on at the moment, probably one of the most exciting things that the folks at the user facilities of BES are likely well aware of is that in FY 2023, we were able to support the user facilities at a new level of funding, which was based on a rebaselining activity that focused on having full operations of the facility that balanced the maintenance and user support and staff support and so on, and took into consideration the impact from inflation and the supply chain cost issues that surfaced post-COVID, increasing our staffing support to allow the hybrid in-person and remote operations. Remote operations were a really dominant theme during COVID and had many benefits to the user community. So to retain that option as well as have in-person activities requires more people and some different kinds of people. And of course, we are in the process of upgrading many of our facilities, and bringing on those upgrades means that additional staff are needed. So that is another aspect. As we reflected on what had happened since the 2018, the last year where the facilities were fully funded, there a lot of maintenance had gone into delayed schedules. So we are focusing on catching up on some of the maintenance. I said the only thing that frustrates a user more is that after they finally get time on a beam line or with an instrument, and then they turn up and there is a maintenance issue that prevents them from being able to do their research. So that is one of the exciting things that we are did for FY 2023. If you look at our facilities, we have upgrades underway at virtually every one. The lone one without a current upgrade underway is the SSRL at SLAC National Accelerator Lab in California, and we are working with them on plans for upgrading some beam lines at that facility to help them again provide better capabilities to the users that come to that facility. Some of these upgrades are being realized. We had the first light for the upgraded capabilities at the LCLS. That was completion of the LCLS-2 project that brought online a superconducting LINAC in addition to their copper LINAC. So very exciting times, and celebrations are underway to celebrate the completion of the project, and as well as the launching of the next generation of science. So it's very exciting to see that. Another facility that is seeing the fruition of its upgrade is the APS, the Advanced Photon Source at Argonne National Laboratory, where recently their entire accelerator has been removed. So at one point, that is the image at the bottom center is what the facility looked like. It was empty. There was no accelerator in place. The components have been brought in. The composition of the new accelerator is underway, and hopefully this system will be up and operating next year. So we are very excited by the progress being made with that accelerator to increase its brightness and its potential for, again, doing new science. Looking backwards, what you'll find is that the research in BES user facilities has impacted many national priorities, priorities in energy, priorities for next generation electronics, quantum information science, manufacturing, and health. And when they originally invited me to join this group, it was to talk about some of our bio capabilities. So I have included that emphasis in the slides just for completeness. If you look at our BES DOE user facilities broadly, there are a lot of resources for doing biosciences research, for doing research that relates to viruses, vaccines, and many aspects of personal health. Health is not part of the BES mission, but it is part of our user facilities mission because it is an important national priority. So as you go around the facilities that BES supports, you will find a lot of capabilities for doing research on biology. You will find the ties to the advanced scientific computing research that brings the dimension of computational research to the bio research. And you will find ties to facilities like EMSL, whose focus is in the biology and environmental sciences regime. So as you look across the DOE system, there are a lot of capabilities. And again, this slide reinforces that from the BES perspective, we are mainly focused on physical sciences, but our world-leading user facilities that include X-rays, neutrons, nanoscience, and a lot of cryo-electron microscopes are co-located with our facilities or are part of our nanoscience centers that are important in biological research. What we found during the COVID crisis is that our facilities were great. They could rapidly pivot to address issues related to COVID. And then, of course, we have a lot of collaborations between DOE and other agencies, including the National Institutes of Health and CDC, and of course, the National Science Foundation, among many others. So if we look at how the Department of Energy responded to the COVID situation, our national laboratories worked together to form what was referred to as the National Virtual Biotechnology Laboratory. And this consortium helped to set priorities and identify opportunities that the national labs could make a difference in the fight against COVID. So in BES, our nanoscience centers were engaged in looking at supply chain bottlenecks, looking at understanding masks and how they worked, and worried about delivery of therapeutics using nanoscience approaches. The synchrotrons, in particular, had a long history of doing characterization of the proteins in various viruses, and that foundation of hundreds of pieces of information from the synchrotron that were available in the national databases were really part of the reason that we were able to have vaccines formulated so quickly. There was a lot of information available. During the actual COVID pandemic, while our labs, like much of the rest of the country, were shut down for many things, we were open and did business in doing additional characterizations of both the COVID structure, but also in the development of the actual vaccines and various other therapeutics for the nation. Neutron scattering was also involved with our Oak Ridge facilities. So this is another summary of the areas that there were COVID impacts. I think that I have likely covered all of this. A reinforcement that the X-ray sources research underpinned all three of the vaccines that were used in the United States during the pandemic, as well as, again, the virus structure research that predated the pandemic. So if you look at it, this is a animated slide, which is rather interesting. So it just looks at how user facilities come together. So in an identification and productions of drugs, we have to target understanding what the structure is, which is involving our neutrons, X-rays, and our cryomicroscopy capabilities. These cryomicroscopes are also funded by biological and environmental research, as well as, of course, the National Institutes of Health have many of these capabilities. We look at how we can take that data and discover through computational tools based on the data what the best approaches might be to look at the inhibitors or the medications for the various viruses. And again, we bring in the neutrons, X-rays, and the nanoscience centers, and looking at the design and synthesis of the vaccines or other medications. And finally, someone else does the in vitro characterization of how things work. So it takes a team that goes across universities, the government, our user facilities, of course, industry, with the pharma researchers and the National Institutes of Health and their important role with the health sciences research for the nation. So there's a few slides, and I'm not going to dwell on these in the interests of time. This is a focus on the sciences advisor that developed Paxlovid using the APS. Personally, when I finally contracted COVID just in June of this year, I was one of the recipients of the benefits of that research and taking Paxlovid to minimize the symptoms that I experienced. The next slide talks about a particular enzyme that was involved with the SARS virus. So this used the LCLS research, the X-ray free electron laser that could look at the structural studies of this particular enzyme and then help to understand how the virus invaded the host immune system. Another example was the development of the protease inhibitors for the virus, again using now neutron crystallography at our Oak Ridge facilities. And then at the Molecular Foundry, one of the nanoscience centers, they worked on peptoids. In this particular example, these are antimicrobial peptoids that impacted the virus's structure. There was also peptoids that were used in actual delivery of the various vaccines or medications for some of the approaches for combating COVID-19. Following the pandemic, or partway through the pandemic, as it turned out, we did do a roundtable to look at lessons learned from the COVID era. These are posted in this report, and they're summarized here. Some of the ones that we really honed in on was that we don't need to wait for the next pandemic to make sure user facilities have the tools that they need for the user community to combat a health-related virus, and that we need to keep the channels open for using the advanced scientific computing to work with our colleagues in biological and environmental research to make sure that we were able to make the best progress when the next crisis, if the next crisis comes. This led to a subsequent roundtable that defined research priorities for biopreparedness, and this led to a Office of Science initiative on biopreparedness research virtual environment, BRAVE, that focuses on integration and coordination of expertise and capabilities that go across both the Office of Science programs, those being OSCAR, the computing organization, BER, Biological Environmental Research, and BES, but also going across the national laboratories to make sure every research is being leveraged across these areas. The ones in particular that BES was focused on with our colleagues in the other parts of the Office of Science were innovations in material sciences that are needed to make sure that we can deal with supply chain issues that may emerge in a crisis, as well as developing the capabilities at the BES user facilities to support this kind of research. So this initiative had a funding opportunity just last year, which was just a few weeks ago when it ended. So the awards were announced on September 7th, and there were 10 awards announced. 4 of them went across the BES user facilities in concert, in some cases with BER, and the other awards were BER and OSCAR led awards. So really exciting times for developing new capabilities to actually better characterize and better integrate what we're doing in this important area. As we look down the road, looking at FY 2024, the request, of course, is been superseded by some marks, and right now we're in a continuing resolution. But the facility budgets have a 15% increase above the 23 enacted, recognizing that we have new capabilities coming online at many of the facilities, and we have a lot of maintenance backlogs, and inflation goes on. Even with a 15% increase, we really can operate the facilities only at about 90% of what they've estimated is their needs for full operation of the facility. But we are very excited that we were able to ask for an increase above 23 enacted in the request. We have lots of construction continuing. There was some investment by Congress through the Inflation Reduction Act that has helped our user facility construction. So in the coming this fiscal year, the only facilities that's construction that still requires funding are the ones listed. The high energy advance for the LCLS, the upgrade to the advanced light source, the proton power upgrade at Oak Ridge, the second target station also at Oak Ridge for neutron scattering, and a cryomodule repair and maintenance facility that will be located at Slack and would serve as a West Coast cryomodule facility for repairs. We have some new projects coming on to replace the pressure vessel and the high flux isotope reactor, important for both neutron scattering and production of the isotopes that are critical for medicine and defense, as well as beamlines at the NSLS-2. We will finalize the funding for the major items of equipment to recapitalize our nanoscience centers and complete the beamlines funded through the, again, NSLS-2 through the next 2 project. An important dimension of what we do is strategic planning. I know that's very important to y'all as well. This is the line of reports that date back probably about 20 years for the BES user facilities strategic planning. Some of the recent ones are at the bottom. I mention this in part because going on right now, even as we speak, is a basic research needs workshop that's looking at accelerator-based beam instrumentation and what are the research priorities moving forward for the novel instrumentation for the beamlines and end stations, transformational advances, excuse me, in the various characterization tools for the detectors, for the optics, as well as cross-cutting topics, which will likely include data. So there's 5 panels, and they should have some initial results out in terms of a brochure on the highest priority research directions early next calendar year. The other thing that we're doing to help Congress understand how important, as well as the taxpayers, to understand how important our user facilities are, is we've started running a series of webinars focusing on various topics and the contributions that the light, neutron, and nanoscience centers are making to those topics. The first one was overarching and covered many topics. We had one on quantum information science on National Quantum or International Quantum Day a few months ago. The most recent one looked at next generation microelectronics and was held in July. The next one will likely focus on one of the clean energy topics, but then we will have ones on biopreparedness again, as well as looking at advanced synthesis and manufacturing. So as I said, these are open to the public and they are well advertised, and I encourage y'all to reach out to friends, family, and anyone to make sure that people know how important our user facilities are to national priorities. My final slide looks at some of the emerging activities that we're working on. This is my final slide. We are continuing the assessment. The costs of operating our user facilities is really important. We want to make sure we have people that have salaries and we are able to maintain maintenance and so on. We want to increase the diversity of our users, as you heard in the previous panel. I don't think I can add anything to what they said. It is really an important topic. We obviously want to continue to increase the impact of our facilities. Data is an important topic. Facilities generate a lot of data, and we hope to take advantage of the analytical approaches, new instrumentation, new capabilities to help that data get turned into scientific impact as soon as possible, but also to help improve facility operations. And this is all going on in concert with with Advanced Scientific Computing Research, our partner activity in the Office of Science. So with that, I will conclude and say thank you very much and happy to answer any questions.
Thank you very much, Linda. There was a lot of information. You are smooth with the delivery of that much data. I'm definitely intrigued at what continues to be the rolling influence of the biopreparedness coming out of post-COVID, and the I got to make sure I have all the acronyms right. The National Virtual Biotechnology Laboratory. So it seems that in the biopreparedness realm and biosecurity realm, I know you weren't saying it this way, but it seems to be alluded very much with zoological diseases. It's a when, not if, and let's make sure we take the lessons learned from last time and be as ready as possible to leverage the resources that we have.
We're doing a lot of investment in automation because if all of your users have to stay at home and they want to send samples in and still make scientific progress during a pandemic, you need to automate things because we don't have enough people to do all the hands aren't there then, there are hands at home. So we're working on automation of the facilities to be able to preload multiple samples, run things overnight, help our user scientists also still have a life. So some of them can run overnight and people can go home and just have alerts sent to them if there's a problem. So a lot of focus is on automation, but that also comes with a change in our staffing because you need the computing capabilities and the experts when a problem happens to resolve it quickly. So yes, so we're also looking at how we can speed up the data flow and maybe be able to use the machine learning kinds of techniques that could predict how an experiment might turn out, and maybe you'll change the parameters before you start it to get the best possible results. It's really exciting. It's a really exciting time. Thank you.
Yes, I would expect. Is there then a lot of opportunities for positions open at some of the facilities or writ large within Office of Science or within BES for the kind of skills that you're looking for?
I presume so, but the facilities would be the ones to be able to tell you that.
Yeah.
I know that there is, like with everyone else, we've had a lot of post-COVID retirements, as well as companies pulling people from our facilities because of the importance of the techniques to what their company is doing. So we've seen a lot of drain as well as opportunities as you articulated. Thank you.
Yes. All right. Thank you. That's just making the wheels turn a little bit of when we have a presence at particular conferences. Often there's the younger sciences down to even some of the more, say, motivated high schoolers who are asking for what opportunities there are and what they could be planning a type of research career path where the options are. All right. Well, thank you very much. This was really a great, helpful update, as well as the focus or the emphasis on some of the biological research as you had. That was intentional.